And complete information about that modal structure would tell us what would happen under free variation of any variables, internal or external, early or late in history. The ones that we care about at a personal level are the ones over which we have willful control, but there are uses too for more encompassing models. For example, models that examine the effects of variation in interest rates on the economy, or models that examine the effects of ozone depletion on the environment. These help us with design and intervention on the larger scale. They help us assess the possibilities for change and assign responsibility. By understanding how this loss of information occurs when one embeds a local model, local causal model, in a more encompassing one, and understands the practical significance of the counterfactual information that's lost when one does this embedding, I think it's easy to come around. And I actually, this wasn't something I started out believing, but I think that it's easy to come around to Pearl's view, announced in the preface to Causality, of seeing the local causal relation as the basic building blocks from which the global models of physics are built. So the idea is, when you go global, you genuinely lose information. There's no good reason for insisting, I think, that the global models of physics have to fully reflect the world's modal structure. It's a bit of chauvinism, I think, in the philosophy of science, that we think that physics has to be, in that sense, complete. And indeed, it's wrong to foist that idea on practicing physicists. It's only philosophers and cosmologists that insist on treating the world as a seamless unit. Practicing physicists work mostly with local causal models, and they're entirely realistic about the causal structure. And in fact, if you're talking to cosmologists, they can only give a sort of vague metaphorical sense to the distinction between initial conditions and law-like features of the world. So I agree with Pearl now when he writes, I used to think that causality simply provides useful ways of abbreviating and organizing intricate patterns of probabilistic relationships, the kinds of probabilistic relationships I said that you can derive from the global loss together with the probability distribution. Today, my view is quite different. I now take causal relationships to be the fundamental building blocks, both of physical reality and the human understanding of that reality. And I regard probabilistic relationships as but the surface phenomena of the causal machinery that underlies and propels our understanding of the world. So, first conclusion, recommend that we should stop trying to derive causal facts from something more basic, for example, dynamical laws, probabilities, pattern of actual fact. These are but the surface phenomena. The real heart of the theory lies in what it says about what would happen under arbitrary, hypothetical interventions, early or late in history. Now, once you've seen, first, how the distinction between endogenous and exogenous variables introduces the idea of a way things might have been, but aren't, by introducing a dimension along which the world can vary with the idea of an exogenous variable. And come to see that how that distinction is something that's introduced by a model rather than something that's inherent in the world. And that the distinction has practical significance from a human-centered perspective in the context of choice. It's a small step to the Copernican move. I'm not attributing this to Pearl or other interventionists, but I think it's a small step to the Copernican move of seeing that the modal substructure that we discern behind the pattern of actual fact is actually a shadow cast by models constructed to guide action. Modeling is a human strategy for coping with a quickly changing environment under conditions of restricted information. We construct models that highlight real patterns that we can use to act strategically. In considering what we do, we represent a range of alternative actions and trace out their downstream effects. This process is our most powerful cognitive tool, one that gives us our primary advantage over other kinds of naturally evolved cognitive systems. And the modal content of our models, what it tells us about what would happen under hypothetical intervention, plays its role here in the context of choice. Science is a form of modeling, an extension of this basic human strategy, involving the collectivization and the systematization of information, construction of models of varying scope. And these models all play a role in interaction with the natural environment. Modal thinking is part of practical reasoning, and practical reasoning is part and parcel of the process that leads to human action. The extra layer of representational mediation between stimulus and response gives us a kind of flexibility and foresight that Dennett in his way in his book and I in my way in mine argue hold perhaps our greatest advantage over natural competitors. In a laboratory setting, and proposed looking at science is just an extension of that strategy. In a laboratory setting, we're always dealing with an object system and treating the environment, usually a collection of identified variables whose values we are particularly interested in, and which we have ways of controlling, as exogenous variables. In everyday context, we're dealing with an open environment and treating our own actions as input to it. We model ourselves too, as, of course, as individuals and as a group, when we take ourselves as objects and look for patterns in the determination of human behavior. Recognizing these kinds of patterns in psychological contexts and social scientific contexts, recognizing these kinds of patterns can help us understand the cultural, environmental, and subpersonal forces that affect our own behavior. So the idea is, look in personal contexts, when you're deciding what to do, you treat your own action as a free variable and assess the downstream effects of hypothetical interventions on the open environment. But of course we can step back and we can take humans as part of human behavior as part of the endogenous variable and look at look at the effects of variation in various cultural parameters or social parameters. One of the things that we find in all of this modeling is that the search for not just for relatively robust regularities with limited scope, but precise regularities without exception, pushes us in the direction both of looking at the very fine structure of reality and of modeling the world as a whole, as a single dynamical unit. So if we're really looking for very strict and precise regularities, we have to go deeper and we have to go wider. The all-encompassing models for which we can formulate these kinds of precise, strict laws are the models of fundamental physics. They don't unseat the more local models with limited scope, but they unify them, they prescribe their range of applicability, they make the environmental infrastructure and frozen accidents that support the local models explicit. Practical considerations define the scope of the model. We construct models for purposes at hand, choosing endogenous and exogenous variables and holding fixed environmental scaffolding in a manner dictated by the problem context. The idea of a non-actual possibility arises with the introduction of the distinction between endogenous and exogenous variables. And the idea of a range of values of that exogenous variables can take. Once we have that idea, the idea of a non-actual possibility, the idea of a way things could have been other than the way they actually are, we can raise all kinds of questions about hypothetical possibilities. But the whole modal superstructure is erected on top of what actually happens. That is erected on top of what actually happens. Depends on a choice, and this is what I see as the insight, the kernel of insight at the heart of the interventionist analysis. Depends on a choice of endogenous and exogenous variables that's introduced by an agent, and that's given content by the possibility of intervention. It's something that has practical significance for an agent choosing between potential interventions.